Morning students. Now we are going to discuss about the even and odd function concept in Fourier series. By using this concept, we reduce our calculation to find out the solution of Fourier series. Calculating a Euler formula a0, an and bn in even add-on function, we find that few of the Euler values are 0. Coefficient value of a0, an and bn, sometimes they are 0. While if we know that the function is even or odd, we initially know that a0 or an or a bn which is going to be a 0 in the coming calculation. What is even function? If x is replaced by minus x in a function of fx and we get the same value as a fx, then it is called even function. Or graphically, if we consider y as a axis or y as a mirror and we find that the left and right side of the y is the image of the same curve, then it is called even function. But for the odd function, if we replace x by minus x, we get minus of fx, then it is called odd function. Like x is an odd function. If we replace x with minus x, we get minus x. X cube is an odd function. X to the power 5 is an odd function. But for even function, x square is an even function. X to the power 4 is an even function. X to the power 6 is an even function. Even a cos theta is also an even function, so that cos minus theta is equal to cos theta. Well, and sine minus theta is minus sine theta, so sine is a odd function. Now if we have to find out the Fourier series for the function ft for the interval 2 pi, period 2 pi, and the interval is minus L2 plus L, and if we know that the function ft is a even function. Even means when we replace t by minus t, we get ft, then the bn will be equal to 0. For this problem, we don't need to calculate the value of bn, and bn is equal to 1 upon L minus L to L ft sine n pi t upon L dt. This is the generalized formula for bn. If we replace L by pi, we get the previous formula which we already studied in a previous PPT. So we only need to calculate a0 and an to find the Fourier series for the function ft, which is a even function. Or we can say that we just only find out the value of cosine function for the Fourier series of ft. If ft is an even function, then the bn will be 0, and generalized formula for the Fourier series of the function ft even for the interval minus L to L is written in the last line of this PPT, that is ft is equal to a0 by 2 plus summation n1 to infinity an cos n pi x t upon dt, where a0 and an generalized value is 1 upon L, integration limit minus L to plus L ft dt is for a0. For an, we just introduce ft cos n pi t upon capital T. Remember, the capital T is inside the cos, that is in an angle. Now we consider if the function ft is odd function and we have to find out the Fourier series for the function ft, like x, x cube, or sin x for the interval minus L to L or period 2L, then a0 and an will be 0. Only the bn will be exist, and the formula for bn is equal to 1 upon L minus L to L ft sin n pi t upon L dt, and this is the only Fourier series for function ft odd function. Fourier series for odd function is just the series of bn sine function, that is ft is equal to summation n1 to infinity bn sine n pi t upon L. This calculation is based on the integral property, that is integration property is if the limit is minus L to plus L, fx dx is equal to 0 when fx is a odd function. Fx is a odd function like x, x cube, or sin x. But if the fx is a even function, then we can say that twice of integration 0 to L fx dx is equal to the integration of minus L to L fx dx. Now we are going to consider an example like fx is equal to x square. That means a function is fx is equal to x square. This is a even function. If we replace x by minus x, we get just x square. For the interval minus pi to plus pi, we have to calculate the Fourier series. So because this is a even function, so bn will be 0. We don't need to calculate the bn. We just write down that the function is a even function for the interval minus pi to pi, so bn is 0. We just need to calculate a naught and an accordingly. And the formula for a naught is equal to 1 upon pi integration limit minus pi to pi fx dx, and the formula for an is equal to 1 upon pi minus pi to pi fx cos n x dx. A naught is equal to 2 upon pi 0 to pi fx dx. 2 upon pi fx is equal to x square over here. So integrating x square is x cube by 3. So substituting the limit x cube by 3 and multiplying by 2 by pi, finally we get 2 pi square by 3. Similarly for calculating the a naught, an, and now we are going to calculate the an, and an is equal to 4 upon n square minus 1 to the power n. For n is 1, 2, 3 and 4. If n is even, then the term is positive. If n is odd, then the an is equal to negative. Now substituting the value of a naught and an in the Fourier series and expanding it, we get the value of x square is equal to pi square by 3 minus 4 times of cos x upon 1 square cos 2x upon 2 square cos 3x upon 3 square with alternative negative and positive signs. Now to prove that, which we have to show in this question, x is equal to pi. Substituting the value of x is equal to pi, we get x square is equal to pi square by 3 minus 4 sum cos pi upon 1 square minus cos 2 pi upon 2 square, and taking the pi to the left side, we finally get our proof, that is pi square by 6 is equal to 1 upon 1 square plus 2 upon 2 square plus 3 upon 3 square and so on. Let's take another example of to find the Fourier series for the function fx is equal to minus 1 plus x for the interval minus pi to 0 and 1 plus x for the interval 0 to pi. Now if we replace x by minus x, we get the value of f minus x is equal to first term for the interval minus pi to 0, we get minus 1 minus x, minus 1 minus x. This value for the second term, we get 1 minus x. Now if fx, and we take minus as a constant or invert multiplying by the minus 1, we get, so f minus x is equal to minus of fx. So finally we know that fx is a odd function for the interval minus pi to pi. So a naught and an will be 0. We just need to calculate the value of bn. And the Fourier series will be the summation n1 to infinity bn sine nx. For calculating the bn, the formula of bn is 1 upon pi minus pi to pi fx sine nx dx. Because we know that fx is an odd function and sine nx is also an odd function. The multiplication of odd function is equal to the even function. So that by using the integration property, we can say that the limit minus pi to pi can be replaced by the limit 0 to pi and twice. Now, in this slide, we are finding the value of Bn. It is just a hint for you, or just we are just checking whether you are working or not. Calculate the value of Bn and verify it, which is presented in this PPT.